Welcome to the Measuring Pi, Squaring Phi website, where we're now going to introduce proof number 7. Proof number 7 is a combination of physically measuring the pi circumference of a 1-unit diameter circle, and also we're going to do the math proof right on the same board. So the first thing we want to show you is that the drawing surface is indeed level. Zero in on our level here. You can see that the bubble is between the two lines. Let's move the level to a couple of different places. Here's one. Once again, it's level. How about this way? It's level. And over here, it's also level. Now that the table is seen to be level, let's look at the equipment that we use, our engineering drafting equipment, some of the equipment we used. There's a T-square, 45-degree triangles, rotary circle cutter, starret, 4-meter measuring tape, and engineering measuring tape, a beam compass, which I have laid out here, and a tape measure to lay out the initial diameter. So we can zero in on the edge of the beam compass, and we see it's on the zero line. Notice it's on the inside of the circle that we have already cut. We will show this again. And if we pan over to the middle, we have the pointer of the beam compass at 500 millimeters. Okay, so you can see that the radius is 500 millimeters, and the measuring tape, in fact, panning all the way over for the diameter, we will see that the beam compass, the tape measure, the 1000 millimeters is on the inside of the circle, not on the groove that we cut around the circle. That groove is for the tape measure to slide into with the hash marks facing inward. We don't want to include the measurement of the tape into the measurement of the circumference of the circle. So that's why it's at the bottom on the inside groove, both here and all the way back over. Let's take a look again past the center. At this point, 0 point is also on the inside of that circumference. Now that we've set up the beam compass to have a radius of 500 millimeters, let's just rotate it around. I had already done this and also did the circle cutter. Rotate it around to show you how the beam compass fits right in the groove, or right onto the inside of the groove. We're going to cut over the circumference, and this goes around and around. It's okay to tilt the compass, and so you see that the compass tracks all the way around. It's kind of tight to the inside of the groove, which is what the beam compass was set to do. We did the beam compass first, so now we have a circle that's 500 millimeters in radius. Then we take the beam, like a beam compass. This is the rotary circle cutter, and we're going to cut the groove. It's already pre-cut. I did it. and rotate this around in the groove. So all the way around, circle, I'll go slow. We cut the groove around the diameter of 1,000 millimeters so that we have a true circle. One more time. It has a titanium blade in here and cut through the poster board so that we can then insert the tape and thus measure the pie circumference. So now we're going to wrap the tape measure around the pie circumference of the 1 unit diameter circle and measure the starting point at 0 and the ending point to find out what the true value of pi really is. So let's set the camera up and get a good clean shot, straight on shot here. Zoom in a little bit. Okay. So we were at the 3100. Zoom in a little closer. Okay. And now let's go around and measure the 0 point and also the ending point. So we're starting out at, of course, 0. We have the starting point is 0 millimeters and the tape is wrapped all the way around. The tape is in the groove and we're at 3100, 10, 20, 30, 40. And let's snug the tape up like we're supposed to. Okay. Leave it in the groove, and we have 3100, 10, 20, 30, 40, 1, 2, 3, 4, a little over half, 0.6. So we have 3, 1, 4, 4.6 millimeters for the pi circumference of this 1 unit circle. So here we are measuring the pi circumference of a 1 unit circle. We wrap the tape all the way around. Here is the start, and here is, we'll snug it up, the tape as we wrap it all the way around. Snug it up a little. We're at 3100, 31, 10, 20, 30, 40, and as you can see, it's 1, 2, 3, 4.5 or 6. It's very close to 6, a little over a half. So once again, there's the 0. And here's 3,144.6.